In this video, we're going to explore ways to find antiderivatives of some atypical functions like this. Okay, so derivative of, the integral of 2 as the base raised to the power of x. So notice that this integrand can be written as e raised to the power of ln of 2x dx, right? And watch my previous video in regards to which identity we have used to transform this into this. And then we can do this further as e to the x ln2, right? Using the properties of logarithms. So now it's going to be really easy, right? Because you can write it as e to the ln2 times x, okay, dx. So now if you use the u substitution, you will be having ln2 times x. So the du will be simply ln2 dx. Okay? So we can write this as e ln2 times x. And let's write the du in here. So we're going to have ln2 times dx. Now notice that ln2 didn't exist there before. That's a constant, so we need to divide this integrand by ln2 in order to eliminate it, right? To eliminate this ln2 in the integrand. So now we will have 1 over ln2, that's a constant, times e. Well, before that, sorry, I forgot to write it in terms of u. So it's going to be 1 over ln2 integral eu du, okay? Because this part is du and this part is u, okay? So now we're going to have 1 over ln2 e to the u plus a constant. Let's put it back in terms of x. 1 over ln2 e, and u was equal to ln2x. Notice that ln2x can be written as well, let me see. ln2 to the power of x. Yeah, ln2 to the power of x, e ln2 to the power of x, right? I'm just going backwards here. I'm looking at this part and then I'm looking at this part, right? Going backwards, right? And actually, notice that you can even write this as 1 over ln2. And what is e to the ln2x? That was this, right? This original integrand, this function, right? So it's going to be ln2, 1 over ln2 times 2 to the x plus a constant. Well, let me actually write it on the top here instead of 1 there, right? So you can see it. Right, so it's going to be 2 to the power of x over divided by ln2 plus a constant. That's it. Right? I just substituted back the original function. Okay, so now let's do another example using the similar technique. Let's separate that. So the function is going to be going to take the integral of x2 to the power of x squared dx. So notice that we can write this integral as x e to the power of ln of 2 to the x squared, right? I know there's lots of powers going on here, but this is basically using the identity in the previous video that we talked about. Watch it carefully. Okay, so it's going to be making it simpler. It's going to be xe x squared ln2, okay, dx. So notice that we can write it as xe ln 2 x squared dx. Okay, so now that's going to be easy because um, the u will be equal to, well, let's see. So u is going to be equal to ln 2 times x squared. The du is going to be equal to 2 ln 2 x. Okay, so there's already an x there to help you, but there's no 2 ln 2. So you would have to divide this integral by 2 over ln 2. Okay, to compensate for that pop-up of du part, which is 2 ln 2. Right, so we're going to have as a result 1 over 2 ln 2, that's a constant outside the integral, that together with that x will give you the du, right? So now we will have e to the u, right? Because we already substitute the u with ln 2 times x squared times du. And once again, du is 2 ln 2 times x times the dx, right? I should have written the dx in here. Okay, so now we're going to have 1 over 2 ln 2e to the u plus a constant. So now let's work our way back into substituting what we originally started with. E to the power of ln 2x squared plus a constant. So that turns out to be, let's work our way back looking at the e here. E ln 2x squared. So we're starting here. So e ln 2x squared is written as e to the ln 2 to the power of x squared, which is the same thing as the original function 2 to the power of x squared, right? So it's going to be 2 to the power of x squared divided by 2 ln 2 plus a constant. Well, actually, we can simplify this even more because I see the base of 2 in there. So it can be written as 2x squared minus 1, right? So let's finish that. Let's write that as 2, wait a second. So 2 x squared minus 1 over ln 2 plus a constant. So there you go. That's your final antiderivative. It's a hectic one. It's crazy, right? But if you understand the identity involved when we took the first step, when we changed the 2 to the power of x squared into the e to the ln 2 raised to the power of x squared, then you'll be okay. Then you'll be able to integrate it easily. Okay? Thank you so much for watching. Please subscribe to my channel, and I'll see you in my next video.